So here's a new situation example. We're told if we're given two angles and a not included side, that is the angle side situation, we use the law of sines again. So let's go through an example like this. And I'm actually going to start off using this form where I have the sides on the top, since I'll be solving for sides right away, and then I have the angles on the bottom. So this is the most convenient way of doing it. So what can we tell? Well, here's a situation. Let's say we're told that we have side A is equal to 7, whatever the units are. Let's look at angle A, and we're told angle A is 35 degrees, and that we're given angle C in this case, so that its opposite, so that its angle is 100 degrees. So now we have to go through and solve for the missing information. So where should we start? Well, probably the easiest calculation to make is to find the length, find angle B. So we're going to start with angle B first, because that's easy, because we know that the internal angles of a triangle must add up to 180 degrees. So the angle size for B will be 180 degrees minus 100 degrees minus, we're going to get it 30 minus 35 degrees. And so we find that angle B is going to be 45 degrees. All right, well, that's pretty good, Professor Peoples. What next? Well, we will also have to find the lengths of each of our opposite sides. So let's start with C, and then we'll go to B. All right, what could we do? Well, in this case, if I find my angle, my side C, I'm going to set it up so that I take the length of my side C divided by the sine of its opposite angle. So C divided by the sine of 100 degrees is going to be equal to the length of, let's go with our given situation, 7, which is side A, divided by the sine of its opposite angle, the sine of 35 degrees. So working this out, we would say that C is equal to 7 times the sine of 100 degrees divided by the sine of 35 degrees. Now, I happened to work out this number earlier on my calculator, and I'm finding that the sine, that side C would be equal to 12.02. Again, I'm rounding this off to the nearest hundredth right here. So that is the length of side C, and then of course I'm going to go for side B. So side B is going to be found by taking the length of side B divided by its opposite angle, and we found that to be 45 degrees. So B divided by the sine of 45 degrees will equal the length of its, let's put the ratios for A to sine of A, so it's 7 divided by the sine of angle A, which is 35 degrees. And this is really just kind of like what we just did in the last calculation. B would equal 7 times the sine of 45 degrees divided by the sine of 35 degrees. And again, I worked out this number a little bit earlier on my calculator, and I found that that value was 8.63. You might verify this on your own calculator just to ensure that I'm doing everything right. But I'm going to go ahead and I'm going to check. So a check right here would be to set up a little table with the sides and the angles opposite of those sides, and just to match to see if the longest side is opposite of the largest angle and the shortest side is opposite of the smallest angle. So in this case, going down the list, side A was given to be 7 and angle A was given to be 35 degrees. We found side B to be 8.63 and angle B to be 45 degrees. And then finally, we found 12.02 for the length of side C, and we found 100 degrees. We were actually given that 100 degrees for side C. So yes, the smallest side is opposite the smallest angle, largest side is opposite the largest angle, so that seems to make sense, and so, well, that's it.